All right, welcome ladies and gentlemen. So today's topic is going to be called completing the square. Essentially, it was nice when we were able to factor things, and we would usually get nice numbers, nice either integer or fraction answers. But quadratics aren't always going to have nice numbers as for answers for zeros where they cross that x-axis. So we want another technique for how to deal with those. And we're going to do that by completing the square. So that's our end goal for today. Today's video might be a little bit longer than other videos, but that's all right. Just hang in there, and we'll get there together. So, first, if we wanted to solve an equation that looked like this, 3x squared minus 4 equals 68. All right. Here, we don't actually have anything in common that factors out. It's not equal to 0. So we've got a whole bunch of things that we want to try to do. This might be a little more straightforward to solve than you might think, so let's just go ahead and talk it through. Our goal is to get x by itself, so let's undo the things that are happening next to this. So we're going to add 4 to both sides. We have 3x squared equals 72. Then if we divide both sides by 3, divide by 3, we get that x squared equals, let's see, 72 divided by 3, that is 24, right? And then after that, we then can take the square root of both sides to make the square go away. So then we have x equals the positive or negative version of whatever the square root of 24 is, since it's not a nice number. It's going to be just a little bit less than 5. All right? But this is a perfectly nice, perfectly reasonable number for us to use for our solution for this particular problem. Okay? So using that same idea, I would like for you to solve this equation. It's x squared plus 7 equals 22. See if you can get x by itself and see if you can find what values x can take. All right? Give yourself a couple seconds, pause the video, and see what you can make happen. All right, hopefully you're able to come up with x equals positive or negative the square root of 15. Subtracting 7 from both sides and then taking the square root of both sides would give us this result. Now, this guy right here, this plus or minus, super duper important whenever you take a square root of stuff. Whenever you're taking an even root, actually, not just a square root, but any even root, positive or negative version of the solution is super duper important. Just to sort of help you figure out why, if we take 2 and square 2, 2 squared, 2 times 2 is 4. But if we take negative 2 and square that, that's going to be negative 2 times negative 2 is also going to be 4. So our square root of 4 is going to be plus or minus 2. Okay? So whenever we take a square root, we want to make sure to have that sort of have that idea in hand. Okay? So next, we're going to solve a slightly different problem. All right, so instead of just being able to solve and take square roots and get x by itself, we want to solve a slightly different problem. Okay, so what we're going to do for that is, let's take a look at a problem that looks like this. So let's say we have, probably would help if I picked up a pen. X squared minus 10x plus 25 equals 27. Okay, so the way we're going to solve this is we're going to try factoring. Let's try factoring this. Okay, so we need two numbers that multiply to be 25 that add to negative 10. And those numbers are negative 5 and negative 5. So if we have x minus 5 times x minus 5, that will give us this guy, equals 27. Now, what we were doing before, when we had zeros, we would normally take and we would say, all right, x minus 5 equals 27, and x minus 5 equals 27. However, we can't do that this time. We can't do that this time because the reason that we were able to do that before is because we would have something times something else that ended up equaling 0. In this case, it equals some different number. Okay, so to deal with that, we want to be able to take and get rid of these two terms. So we can do that by saying, well, since these are the same, let's just make it x minus 5 squared equals 27. Okay. This, if you recall, was one of those special types of factoring things where we had a squared plus 2ab plus b squared. This was that special factoring that I told you about, that we looked about before we ended up with all the craziness. So that's how we got down to this, x minus 5 squared. Now, to get this by itself, same idea, we're going to square root both sides, and we get x minus 5 equals positive or negative square root of 27. And then from there, we can add 5 to both sides, and we get x equals 5 plus or minus the square root of 27. And that would be our solution, our pair of solutions for this particular problem. All right? So I'd like for you to solve this particular equation. Solve this particular equation for x. Using the same ideas that we did over here. Factor this side. Once you factor this, you should get 2 squares. And then take the square root of that and take the square root of both sides, and that should give you your solution. Okay? So to take a couple seconds, pause your video and try to solve this one on your own. All right, hopefully working through, you at least got to right here. But if we factor this guy, we get that x plus 4 squared equals 49. Taking the square root of both sides, we get that x plus 4 equals either positive 7 or negative 7. And since we have x plus 4, we can subtract 4 from both sides. We get x equals negative 4 plus or minus 7. So from here, this is where we stopped over here, because there wasn't much further that we could go. We had both the 5 plus the square root of 27, 5 minus the square root of 27. But over here, we can actually keep going and get nice numbers at the ends. So if we take negative 4 plus 7, which is this side, or negative 4 minus 7, that'll give us this side. Ooh. All right. So then, once we add those together, we get that x equals negative 3 and x equals negative 11. Those are the two solutions for this particular equation. All right. Okay, so I apologize. I had my audio off for that whole portion. So essentially, recap, perfect squares. We're trying to force these perfect square trinomials to happen. Okay? So our question is, how can we find out what will happen? What do we need to put in here so that way we have this thing of that form a squared minus 2ab, or a squared minus 2ab plus b squared? What has to go in here? Well, we have to figure out what b is. All right? We have to figure out what b is. And in this case, what we need to end up doing is we need to... Guys, hang on a second. I'm popular. All right, unpause recording. Microphone's down. Good, wonderful, perfect. So our goal is to try and figure out how we can force this to happen. And so the trick is there's a quote unquote a trick where we can say, all right, if I take whatever B is, so in this case, don't worry about this stuff, but if we have our eraser, excuse me, pick up the eraser, please. Why are you not picking up the eraser? So the trick is, if we have our ax squared plus bx plus c type scenario, then we want to take whatever b is and take b over 2 and square that. Whatever b over 2 is, if we square that and add it onto the end, it'll give us the value that needs to be in here. So if we take this guy here, it's just 2 over 2, and square that. So 2 over 2 is 1 squared, which is 1. We can take 1, plug it in up here. If we add that, we now have a perfect square trinomial that factors to, x minus 1 squared. Whatever number you're putting in here, take this sign, attach it in the parentheses. Whatever number you're putting in here goes at the end, and that's your perfect square trinomial. Okay? So, let's have you do one on your own. So, what would the number you need to add be for the term x squared minus, or excuse me, let's do a plus, x squared plus 5x. What number would you have to add in order to complete the square? Okay, take a couple seconds, see if you can figure that out. Again, use the same idea from over here. Okay. So to find the number that goes in the box, that goes in that is our completing the square value, you're going to take whatever b is, divide it by, in this case b is 5, divide it by 2, square that. Then you're going to take top times top, bottom times bottom. 5 times 5 is 25, 2 times 2 is 4, and then, so that's going to be 25 over 4. That is our completing the square value. So when we have that completing the square value, we now have x squared plus 5x plus 25 over 4, and that is going to factor down to x plus 25 over 4 squared. Okay? Cool. So that is finding that value that completes the square. So now that we can find that completing the square value, we can use this idea of completing the square to solve equations. Okay? So in order to solve a completing the square type equation, here are steps that you can take to get there every single time. All right, steps 1 through 6. So we're going to work through a problem, and we'll just go through each of these steps to solve this. All right, so we're going to start off with something pretty straightforward. We want, let's do orange. So let's do x squared plus, or excuse me, x squared equals 27 minus 6x. Okay, so first, step 1. Collect all the variable terms on one side of the equation and the constants on another. So anything that has a variable, we want to move onto the first side of the equation. So I'm going to take this 6x and I'm going to add 6x to both sides, plus 6x. All right, so that crosses off there, and then we're going to have x squared plus 6x equals 27. So now that we did that, we can check off step 1. If necessary, divide both sides of the equation by a, so whatever number is in front of x squared, to make the coefficient on the x squared term 1. Please stop doing that. Okay, you're still going to do that every time. Okay, wonderful. To make the coefficient on that x squared term, I'm going to make this 1. So here it is 1, so we don't need to divide anything. So cool, done. Now we want to complete the square by adding b over 2 squared to both sides. So we're going to take b, so we're going to take 6 over 2, we're going to square that, and that's going to be 3 over 2 squared, which is 9. Okay, so 6 over 2 is 3, 3 squared is 9. So we're going to add 9 to both sides, plus 9 plus 9. So we're going to have x squared plus 6x plus 9 equals 36. Okay, so we completed the square by adding b over 2 squared to both sides. Then we want to factor the variable side. So this guy factors, it's a perfect square trinomial, so it factors to x squared plus, not x squared, what am I doing? Not x squared, just a plain old x. Boop. So it factors to x squared, or just x, plus 3 squared. Whatever number you get in here, so this became a 3, and we squared it, which became 9. This number right here that you're squaring also ends up inside your parentheses, okay? X plus 3 squared equals 36. We factored that variable side, done. Now we want to take the square root of both sides, take the square root of this, take the square root of this. Sometimes this side won't be a very nice number, and that's okay. But this time it's going to be plus or minus 6, positive or negative 6, and then this side's going to be x plus 3. So we took the square root of both sides. Now we need to solve for the values of the variable. So we're going to get subtract 3, x equals negative 3 plus or minus 6. So x equals negative 3 plus 6, x equals negative 3 minus 6. So negative 3 plus 6, x is going to be 3, and x is also going to be negative 9. So those are the two values that if you plug them back in to your equation, you'll get a true statement. Okay, and we did that. That was completing the square process. Okay, and just there we go. Okay, perfect. All right. So now what I want you to do, actually, what I want you to do is solve a similar problem. Let's go for 2x squared. Let me actually do it in a different color. 2x squared plus 8x equals 12. Okay, so go ahead and take a couple seconds, pause the video, solve that, use these steps, solve this equation, find out what x is using that completing the square process. All right? Pause your video, give yourself a chance to solve this. Welcome back. Hopefully you found something along these lines. Hopefully your answer was x equals negative 2 plus or minus the square root of 10. So we got that by starting off with this equation. First, we collect all variable terms on one side of the equation and constants on the other. Luckily, that was already done for us, so we check that off. If necessary, divide both the sides of the equation by a to make the coefficient of the x squared term 1. So here, our coefficient of the x squared term was not 1, so we had to divide everything by 2. When you're dividing everything by 2, make sure you divide everything by 2. So this 8x should have become a 4x. All right, and this 12 should have become a 6. So then, once we divide both sides by 2, then we need to add b over 2 squared to both sides. So b in this case was 4. 4 divided by 2 is 2. 2 squared is 4. So we added 4 to both sides. Adding 4 to both sides gave us this expression on the left and then 10 on the right. Factoring the expression on the left, added that, good. Factoring the expression on the left gave us x plus 2 squared. If x plus 2 squared equals 10, when we take the square root of both sides, we get that x plus 2 is equal to the square root of 10, or positive or negative the square root of 10. Whoopsie daisies. Once we have that, then we can say, all right, we want to get x by itself, so we subtract 2 from both sides, and we get x equals negative 2 plus or minus the square root of 10 for our solution. And that is completing the square. Make sure you are doing these steps every single time you are trying to solve a completing the square problem, and you should have no issues. Okay? So that is it for today. Thank you so much. I apologize that this was a little bit longer, but hopefully we got there. I will have an assignment for you. Make sure you complete that assignment on Classroom. I will talk to you guys tomorrow. Remember, live at 1-ish today. All right? See you then. Bye.